Dear students, welcome to another video tutorial on data structure of the algorithm. And today's topic is linked list, count, reverse, and search. So we have to count how many data are there or how many nodes are there, and we have to print all the nodes in reverse order, and we have to search a particular number from the linked list. Okay. So myself Niladri Shekhar Pak, I am working as an assistant professor at Greater Kolkata College of Engineering and Management at Computer Science and Engineering Department, and the college is under JIS Group. Okay, the college is situated at Baroda. So at first we will do a C program to count the number of nodes in a linked list. Okay, so let's do. So this is the C editor. Okay, new, go to source file. Okay, we will write the program. At first the header files will be written. Okay, stdio.h. Next we will take another header file, that is conio.h. Okay, next we will take the global variable struct. Okay, struct node has been created. It has two parts. One is the data part and one is the next part. So type of data is int and type of next is struct node type. Okay, so struct node pointer next. Okay, pointer get. Okay, now we'll call all the or declare the functions. Okay, the number one is create list. Okay, a variable needs to be passed. Okay, the next one is int count nodes. Okay, int count nodes. Next one is void display list. Okay, so this is int main. Okay, so int in comma total printf enter the total number of nodes. Okay, total number of nodes. Scanf percentage d comma and percent n. Okay, next we will create a list. Okay, we will call that function. Next we will display the function. Okay, we will display the function twice. One is before counting and another one is after counting. Okay, so data in the list. Okay, so data in the list. Next we will call the display list function. Okay, next there will take a variable total. Okay, so in the total we will call the count nodes function. Okay, this is the count nodes function. Okay, so after we get the number of nodes at the total, we will print the value of total. Okay, so printf total number of nodes is percentage d. Okay, so this is total. Okay, and this is written 0. Okay, so this is the main function. Okay, so now we will define all the functions one by one. Okay, so at first we will, so this is void create list. Okay, create list, a value will be passed. Okay, int n struct node pointer no new node pointer temp. Okay. Next one is int data comma I. Okay. This is the struct node pointer. Okay. So malloc size of struct node so if head equal null, we can print it as unable to allocate memory. Okay. So you go to the else part. Else part will insert one by one element. Okay. So printf enter the data of node 1. Okay. Next scanf nf ampersand data. Okay, so data is taken through input. Next head of data will be data. Okay. And head of next will be next. Next temp equals to head. For I equals to 2, I less than equals to n. Okay. I plus plus. So equals to struct pointer malloc size of struct node. Okay. So if new node equals to null, okay, we can say that there is unable to allocate memory. Okay. Unable to allocate memory. Okay. So there is a break statement after it. Okay. So in the else part, we will input the data one by one. Okay. So enter the data of node percentage d. Okay. That is the value of I. Okay. And scanf percentage d comma ampersand data. So new node is data equals to data. Okay. And new node next is equal to the next part. Okay. After that, temp of next will be so temp of next will be Okay, temp of next will be next new node. Okay, okay. Next temp will be temp underscore next. Okay. So after this, we can print that we have successfully. Okay, this can be printed. Okay, then file list else is completed. Yeah. Okay, so we can print that printed that the successfully added. Okay, so linked list created successfully. Okay. Then there is a new function that is in count nodes. Okay. So initially the value of count is 0. Okay. Then struct node equals node. It is pointer 10. Okay. This is another variable of node type. We can say that temp equals to head. Okay. So while temp is not equal to 0. Okay. The value of count can be increased by 1. Okay. So next temp will be 10 next. Okay, temp will be 10 next. Okay. So after that we will return the value of count. Okay, so return count. Okay, now we will define the display list function. Okay, display list. Okay, struct node pointer 10. Okay, so head equal null. Okay, we can printf that the list is empty. Okay, the list is empty. We can say that. Else will traverse. Okay, so temp equals to head. Next, while temp not equal to null. Okay, we can print that data equals to percentage d. Okay, so whose value will be print? Temp data will be print. Okay, so temp data. Okay. So after that temp will be temp next. Okay, temp next. So we'll now save the program. Okay, save as. Okay. Dot c. Okay, let's execute the program. Okay, so there is an error. Okay, just checking saving the program and executing it. Okay, so there is also an error. Okay, let's check where is the error is. Okay, there is another error. Okay. Okay, so let's run the program now. Okay, so enter the number of nodes, suppose 4. Okay, so 2, 4, 6, 7. Okay, so these are the numbers and this is the number of nodes. Okay, so this is the program to count the number of nodes in a program linked list. Okay, this was the program to count the number of nodes in a linked list. Okay, so next is reverse of a linked list. Okay, so what are the steps? Number one step is we have to create two more pointers other than head, namely previous node and current node. That will hold the reference of previous node, okay, and current node respectively. Make sure that the previous node points to the first node, that is head, and head should now point to its next node, that is the second node, okay, and current node should also points to the second node, okay. So as you can see that this is the previous node and this is the current node. Okay. So there are two variables was taken. One is previous node and the second one is current node. So the current node is basically head is the current node. Okay, and this is the previous node. Okay. So in the step 2, now we disconnect the previous node, that is the first node, from others. Okay, we'll make sure that if it points to none, as this node is going to be our last node. Okay, so we have to perform prev node next equals to null. Okay, so this link has been disconnected. Okay, next one is in step 3 we have to move node head move. Okay, node move to its next node, that is head will be head next. Okay, so the head has been shifted to the next node. Okay, next we will reconnect the current node to its previous node, that is current node next equals to previous node. Okay, so we can see that the current node is next is equal to previous node. Okay. Mm. So this is the step 5. We have to point the previous node to the current node and current node to the head node. Okay. That means they should now point to the previous node equals to current node and current nodes will be assigned as head. Okay. So as you can see that the previous node is the current node and current node is head. Next steps. We'll repeat step 3 to 5. Okay, till head pointer becomes null. Okay. So this is the head pointer. Okay, so head pointer is right now here. So okay, so now after all the nodes has reconnected, okay, as you can see that all the nodes are reconnected. Make the last node as the first node. That means the head pointer should point to the previous node pointer. Okay? So the last node will be the first node. Okay, and perform the operation, that is head equal to prev node. Okay, so finally we will end up with a reverse linked list. Okay, so this is the original. Okay, this is the head and this is the linked list. Okay, so let's do this program. Okay, okay, so let's do the program. This is the hash include stdr.h. Okay, next hash include canary.h. Okay, then we'll take the node structure. Okay, there's two part. One is the data part and the second one is the node part. Okay, that is the next part. Okay, so struct node point to next. Okay, so this is the head. Okay, so let's declare the functions. Void create list. Okay, so this is void reverse list. Next one is void display list. This is the int name. So int and choice. So printf slash n, enter the number of nodes. This is the scanner. Okay. So we'll call the create list. Okay. Next we will display list, call the display list function. So data in the list. Okay. So the function is display list. So printf press 1 to reverse the order. Okay, order. Linked list. Okay, this is the printf statement. Next we will call the reverse list function. Okay, so scanf %d comma ampersand choice. Okay, so if choice equal 1, we can say that we'll call the reverse list function. Okay, next we will printf the data again. Okay, so data list, data in the list. So we call the display list function. Next we will return the statement. Okay, so this is return 0. Okay, now we'll define the functions one by one. Okay, so the first one is void create list. Okay, this we have already discussed in our previous program, the program how to create a list. Okay, so as you can see that this is the create list function I have already defined in our previous videos also. Okay, these are the two variables, new node and tape. Okay, these are the variable data I. Okay, head has been created. If head is null, then you can say that the unable to allocate memory, and in the else part, okay, we have the inserted the data. Okay, so here new node equals to the node has been created. If it is null, then we cannot insert. Otherwise, we will insert the data in the linked list one by one. Okay, so the linked list has been created. Okay, so this is the code for linked list creation. Okay, so this is the code for linked list create list. Okay, so the linked list has been created. Okay, the linked list has been created. Okay, next we will call the reverse function. Okay, next we will call the reverse function. So let's write the void reverse list. Okay, so we'll take two variable as I have explained earlier, that current node and previous node. Okay, so this is the prev node. Okay, and the next one is the car node. Okay, so if head not equals to null, okay, we can say that previous node equals to head, or we can say that current node equals to head next. Okay, and head will be head next. Okay, and then previous node will be next will be previous node next will be null. Okay, so while head not equals to null, okay, then head equals to head next. Okay, current node is equals to next equals to previous node. Okay, and previous node equals to current node. Current node equals to head. So head equals to previous node. So printf will be reversed. Okay, we can print this message. Okay, reversed successfully. Okay, now we'll write down the display function. Okay, so this is the display list function. It will display all the nodes in a linked list. We have already did it in our earlier program, so I have just copied it. Okay, so I'm discussing it. Struct node temp is a variable, okay, of node type. Okay, so if head is null, then we can say that there is no node in the list. Okay, otherwise there will be any node. Okay, so will the temp will be go up to whether it will not get any null. Okay, so we will print all the elements one by one. Okay, so this is the display list function. Okay, so we will check whether head is null or not. If head is null, we can say that the list is empty. Okay, if head is not null, that means that there is any elements are there. Okay, so we will take the temp as head. Okay, and we will go through temp one by one. Okay, and all the elements will be printed. Okay, so this is the code for reverse a node in a linked list. Okay, so let's run the program. Go to execute, compile and run. Okay, so enter the number. Roll number is suppose 4. The numbers are 12, 6, 9, 7. Okay, 12, 6, 9, 7. We will press 1 to reverse. Okay, so you can see that all the numbers are in reverse order. Okay, so 7, 9, 6, 12. Okay, we have inserted 12, 6, 9, 7 and 7, 9, 6, 12. These are the reverse order. Okay, so this is the program to reverse an element in a linked list. Okay, so next check what is there. This is the search an element in a linked list. Okay, so the step one is input element to search from the user. Okay, store it in some variable, say key to search. Okay, so we'll store the number which we want to search in a variable called key to search. In step 2, we will declare two variables, one to store index of found element and the other to iterate through list. Okay. If the index value is 0, okay, and struct node pointer card node equals to head. Okay. So if current node is not null and its data is not equal to key to search, then increment index and move current node is its next node. Okay. In the step 4, we will repeat it step 3 till current node not equals to null and element is not found, otherwise we have to move to the step 5. If current node is not null, then the element is found. Okay, hence we will return index, otherwise -1. Okay, so now let's do the C program to search an element in a linked list. Okay, so let's write the program. So at first we'll take the header files hash include stdio.h. Okay. Next conio.h. This is this int main. Okay. So let's do the variable declare first, global variable, that is node. Okay. So this is struct node. Okay. So there are two parts, one is the data part, one other is next part. So it is struct node pointer next. Okay. This is the head part. So this is void create list. This is int m. Next one is void display list. Next one is int search. Yes, so this is int key. Okay, next we will start the main function. Okay, so let's take the variables. Number one is n. Next one is key to search. Okay, as we have declared key to search. Next one is the index. So printf enter the number of nodes. Scanf percentage d comma ampersand in. So we'll call the function create list. Okay. So in the create list we have to pass the parameter that is n. Next we will print the data in the linked list. Okay, so data in the list scanf percentage. Sorry, I did not record it. I will just display the list. Okay. Next we will take the value which we want to search. So printf /n enter the element to be searched. Okay, enter the element to be searched. scanf percentage d comma ampersand key to search. Okay. So the index is equals to the variable. We have to call the search function, and within this we have to write key to search. Okay. So if index equal to 0, we can say that the element is found. Okay, we can say that the element is found in the list. Okay, at position percentage d. Okay. We'll print key to search search and index plus 5. Okay. Index plus 5. Next we will return 0. Okay. Next we will return 0. This is the end of the main function. Okay. End of main function. Okay. So we will now define the functions one by one. Okay. So today first we will define the create list function. Okay. Because it was at first the link will need to be created. Okay. So the link has been created. I have copied the code, okay, from the previous program. As you can see that the struct node, new node, okay, I have already discussed, okay, how to create list. So this is the code for how to create a linked list. Okay. Basically next we will do the display. Okay. We will next print will display this. So while display, we will display the linked list now. Okay. So we have taken is the display list function. In the temp is the node type. If head is null, the list is empty. If head is not null, then we'll print all the elements one by one, while we will not getting the next as null. Okay. So next we will call the search function. Okay, the main function where the searching will be done. Okay. So this is main search. Okay. We have to pass the key, which element we want to search. Okay, so this is int index extract node current node. Okay. Index equals to 0. So current node equals to head. Okay. So we can say that the while current node not equals to null. Okay. and current node data is not equals to, okay, value of index will be increased by 1 and current node equals to current node next. So we'll return current node not equals to null. Okay, this is there is a ternary operator. So if it is null, then the index will be minus. Okay, this is the search option. Okay, let's save the program. Okay, so let's execute the program, compile and run. Okay, so number of nodes, suppose it is 5, number is 34, 56, 76, 23, 4. Okay, these are the elements. Enter the element to be searched, suppose 76. Okay, so 76 is found with the position 3. Okay, 1, 2, 3. So this is the program to search an element in the single list. Okay, the code. Okay, so this is the code. So hope you have understood the program. Okay, you please check once again. Okay, whether if you have any doubt, any query. Okay, you can call me or you can write on the comment section. If you have liked my video, you can subscribe my channel or you can visit www.facebook.com/digitalclassroom to get all the details and like my page. Okay. So students, thank you for now. See you in the next video.